Now we're going to look at the division by primes method. And it is true, this method is not in the textbook, but it is so easy. So I'm going to teach it to you, and I'm going to ask you guys to learn it because it's actually my favorite method. I think it is the fastest, it's the most efficient, it's the easiest. It's one-stop shopping. You do this method once and you get the GCD and the LCM at the same time. So we're going to divide by prime numbers. That's the big kicker. You do need to divide by prime numbers that are common to both. And then I'll show you once we're done with it how you get the GCD and the LCM. So it's kind of like we saw division by primes as another alternative to factor trees. So this is very similar to that. So you're going to come down kind of towards the bottom of the space you have provided, and you're going to write down both of the numbers. We're going to find the GCD of 108 and 120 and the LCM of 108 and 120. So the point is to figure out what the common factors are. So find a prime number that will divide into both of these. And since they're both even, I think 2 is a great number to start with. So we're going to divide by 2. 2 goes into 108 54 times. 2 goes into 120 60 times. And then you just keep dividing to see, is there another common factor? Well, 54 and 60 also both even. So let's divide by 2 again. 2 goes into 54 27 times. 2 goes into 60 30 times. Now we can't divide by 2 anymore, but is there a common factor we can divide by? Something that will divide into 27 and 30. Well, 3 will, so let's divide by 3. 3 goes into 27 9 times. 3 goes into 30 10 times. Let's see if we can keep going. Is there a number that will divide into 9 and 10 at the same time? No. So at that point you stop once they're what we call relatively prime. Okay, they're prime relative to one another. They don't have any factors in common. This is where we're going to stop. The GCD is the product of all the common factors on the left. So these common ones, that's the GCD. You multiply those together and you're going to have your GCD. So the GCD of 108 and 120 will be 2 times 2 times 3. Which maybe you can multiply that in your head. It's 12. So that's how you get the GCD. You just pull the numbers that are along the left-hand side. To get the LCM, you're going to do like an L shape. Okay, you're going to grab the common factors and these little leftovers on the top. So if you think of like an L shape, but you kind of turn your hand, I know it's a stretch, just go with me. So that's kind of like L-shaped. That's how you're going to get your LCM. So the LCM of 108 and 120 is going to be 2 times 2 times 3 times 9 times 10. Those are those leftovers up there. And if you multiply all of those together, you get 1080. You can use a little calculator to multiply them together, but you'll get 1080. So we've got a GCD of 12 and LCM of 1080. So it's either the left side or it's an L shape. And it goes right along with prime factorization. It's the common factors and then leftovers at the top. Why I really like this method is because it also works very well for 3 numbers. And you can do any of these methods if you're finding GCD or LCM for 3 numbers, but this one seems to be the most efficient and it works out the nicest with the least amount of hassle. But we're looking for numbers that divide into all 3. So we've got 90, 105, and 315. Those are the 3 numbers. 90, 105, and 315. So let's see if we can find a number that divides into all 3 that's prime. We can't use 2 because these 2 numbers are not even. But I think 3 might work. Let's see. I know 3 will go into 90. Let's add the digits. 5 plus 1, that's 6. 3 will go into that. 5 plus 1 plus 3, that's 9. Oh, 3 is going to go into this one. Also 5 will go in here. Maybe if you saw that they end in 0s and 5 and your first thought was 5, you could do that. 5 goes into 90 18 times. It goes into 105 21 times. It goes into 315 63 times. Okay, you could have divided by 3 first if you wanted to. It's totally fine. But 5 works. Try to get the numbers a little smaller. Now 3 should still work. Like if 3 divided into the original 3, it should still divide into these. So 3 goes into 18 6 times, 3 goes into 21 7, 3 goes into 63 21. And then we're looking, do 6, 7, and 21 have any common factors? It's not 2, it's not 3, can't go any bigger than that. So at this point you're done with the division. This is your GCD. I'm not going to write out the 3 numbers again. It's just going to be 3 times 5, which is 15. So the GCD turns out to be 15. And then if you want the LCM, you got to loop and take everybody here. So like an L shape. So the LCM is going to be 3 times 5 times 6 times 7 times 21. Well, this just got really big, right? If you multiply all of that together, you get 13,230, which is another reason I really like this method, because it's the simplest, especially when you get LCM numbers that are really, really big. So what this is saying is the first time that 90, 105, and 315 meet up again, if you do multiples, is not until 13,230. So that is the division by primes method.